Okay. So with regard to GCP, I'm not so sure how the resources were grouped together or segregated. But in Azure, we actually have a management group and then the subscriptions and then the resource groups. So we can actually have a single account for creating the multiple environments within a single Azure account. Uh, and we can
One
actually,
thing, sorry, rather to interrupt you. Yeah, one correction. We are also posting it on Azure only.
oh,
Yeah,
okay, you're going to go with Azure. Okay, that's fine then.
yeah.
Okay, so let me open the Azure thing. Okay, so I'm here in this Meti account, and here, so basically Azure supports the subscriptions, the multiple subscriptions, but here we are using a single subscription, that is the Meti subscription currently. So within one subscription, that's the Meti subscription, we can create a number of resource groups so that we can segregate all of our resources into different resource groups, and we can manage the billing. We can actually even monitor the usage and everything. So uh, so here in this resource group section, we have a different resource groups. Like say, for example, if you take Ulka alone, we have a Ulka prod and Ulka stage. So this resource group is responsible for the resources that are being used in the prod environment, and this resource group is for the stage environment. And the dev environment is actually on another Azure account, completely on a different Azure account. So we don't have any resources or for dev environment here. But if you are creating a dev also here, then we can create another resource group with the name Ulka dev or something like that. So whenever you have a same resource of you created a same VM for Jenkins in Ulka stage and the prod and even dev, you can have a same names because they were grouped within the resource group. But if you are trying to create the resources directly under the subscription without um, depending on the resource group, then the name should be unique and you cannot create the same Jenkins server differently. So it's better to segregate all the resources into different resource groups. So if I take you to Ulka Prod, that's the resource group where we have different virtual machines, different network security groups, different disks, everything. Key vault, public IP addresses, network interfaces, storage accounts, everything. So all the resources which we need for Ulka production environment, we have created here. And a few of these resources were interlinked. Like this disk is interlinked resource with the Jenkins VM. Similarly, we will have a network interface, and sometimes even we will be having a network security group as well, and sometimes even the public IP addresses and all. So this is the production environment. Similarly, we have another resource group for the stage environment. We have all the stage related um, resources, similar kind of resources. And this is the name is actually a differentiation between your resources when you wanted to point to a particular resource under a particular environment. Even when you're using a Azure CLI to manage your resources through a PowerShell script or a shell script or a simple command line Azure CLI tool, then you have to use the resource group with this particular name. One option, one parameter will be there with that Azure CLI commands so that it will actually communicate with the resources there under this particular resource group with the option. Um, okay, so for Ulka, we have a dev environment that is being used by all the developers and even the testing team. Like whenever they have made some changes, they can do their builds through Jenkins pipelines, and they can deploy directly without even notifying the team. And then they can test by themselves. And then once they feel that is good, then they can ask your team to validate once again. And then they merge the code to a master branch using a pull request. And then they build and deploy to stage environment. once that is being deployed to stage environment, that has to be validated again by the QA team, sometimes the users. And once that all been accepted, then the DevOps team will do a deployments to a production environment. Other than the DevOps team, no other developer will have access to deploy to a production environment. And only for the dev on stage, the developers can deploy something. And dev environment, they have everything access like logs, they have access to MongoDBs or whatever is the DBs which we are using in the application. So all those can be used and connected by developers. But when it comes to staging, a minimal access will be there. They can have something, but when it comes to production, zero access to the developers. That way we manage in any organization. And here in Ulka and Toronto also, we follow the same kind of methodology. And currently, a DIC team is in a process of taking over that production environment. So currently, the DevOps team from Toronto is handling the deployments, but going forward, the DIC team will do that. But the developers will not do any kind of deployments to production environment, because if someone does the deployment without notifying the team or the end users, then there will be a problem, and that might cause some issues in the website. So to avoid those things, the production deployments or even the production environment itself, everything will be blocked from the access to our developers. But the logs can be exposed through some external tools like Elasticsearch and something. Okay, so this is how we follow the environment structure. Do you have any questions before we proceed with Jenkins?
No, nothing as well.
Okay. So Jenkins, so as of now, we are using a single Jenkins that is deployed in the dev environment, and that is responsible for building the code, deploying the code to all the environments, including develop, production, and staging. So with one Jenkins, we can achieve everything. So we don't need to create a multiple Jenkins servers and create the Jenkins pipelines. And also it's a single Jenkins is being used for the whole Ulka website. So here we can actually segregate the pipelines using the folder structure so that it would be easy to manage them, and even give the access to the developers at a folder level. So uh, so you can manage simply. So I created three different folders for develop, production, and staging. And within the develop, we have a different folders. Currently, these are the two major folders we use regularly, and these are others. I'll explain you later. But if you take a build, this is the build process where we create individual pipeline for each and every API we have or the front end application we have in Ulka. So this is actually is trying to download the code from the GitHub repository and then build the code using the Docker file and then upload the Docker image to a Docker hub. That's all this pipeline does. And here there are two files are existed in each and every source code, a repository or maybe the folder structure which is associated with this pipeline. They are called Jenkins file and the Docker file. Those are the two files which will be used at the time of the building of the code by this Jenkins file, Jenkins pipeline. So let me take you to a one source code. For example, if we take this Ulka application, oh no, I think it's not the one. This is the one. Okay. Okay, for example, if we take this pipeline, ASR model compute, this is the one pipeline for building the ASR model compute API. And for that, we have a source code is located in this particular folder path. And if you look at here, so we have a Docker file. And sometimes the Jenkins file can be replaced with an sh file, because Jenkins file can contain internally a shell script along with the Groovy script. Either you can create the Jenkins file as an outer layer of Groovy, and within that an inner layer of shell script, or you can simply create a shell script like a start.sh or something like. And this the Docker file. Docker file will contain information like, I think you most of you already aware that, okay, from where this main parent image to be downloaded, and what is the image version, image name and all, and what kind of installments has to be done and all. And then the start.sh will have a sorry, just a second. Sorry, build.sh. Sorry, I'm sorry, I bit confused it. It's not a start.sh, it's a build.sh. It has a standard code of 5-6 lines. This is the common code. You can simply copy and put it in every API. We just need to copy this build.sh file, and that's it. So this is about to add the image name to a image that we are building through Docker file, and log in into the Docker Hub whenever we are trying to push the image, and then pushing the image with our Docker Hub registry and the image name and the image ID. These are the standard 5 lines of code we use. So I think Shoonya is also part of Taranto, so we can use the same Anvad.io GitHub repos, sorry, the Docker Hub repository for pushing the images, and then we can use those images at the time of deployment. So you can simply copy these 5 lines of code, 5-6 lines of code, and then we can use this as a start point of the Jenkins pipeline. We are actually reading the Git revision, the current revision of the Git, and then we are actually assigning that to a build ID, and then the build ID will be from the Jenkins pipeline, and then we are using the revision ID, and then that's called the commit ID or the image ID. And then we are building the image, and then we are pushing the image after we log in. So this is all we do with this build.sh. And then while we are doing this, we use a Docker build that automatically uses the Docker image building, and then it creates everything. Um, the Docker file will be used for preparing the Docker image, like installations, whatever you need at the time of building the Docker. So these are the major 2 files which we need. And
One
if
quick question, Raja.
sure.
You provide the credentials in Jenkins itself, this Docker of credentials,
Yes,
which are not here. Okay.
yeah, we created through our settings the a credential section. I'll show you that. I'll show you that.
Okay.
Okay, so if we go to this pipeline, and then you just simply do a configure, and we are passing the image name. So always when we build this particular API, this is the name to be attached to the image. And the image ID anyway comes from the build ID and the revision ID, but the base image name will be a parameter which we are passing, a parameterized string value we are passing, and where is your source code located, and if your source code has any credentials even to read the code, then you need to add the credentials, and you have to pick the credentials, then only the source code can be downloaded. But this Ulka repo is the publicly readable repository, so we don't require any credentials here. And the branch to build, currently we are building the develop branches from some feature branches. They are defined by the developers as of now, but we are going to make some changes to our Jenkins pipelines in the next week, that this branch can be selected by the developers when they wanted to do a build of any API within the develop section. But currently the branch was specified here. And the Docker Hub credentials, we are just passing that. These are my credentials are stored in the Jenkins credential section for the Docker Hub, and I'm converting my Docker Hub username with this username variable and this password variable. So whenever I want to access the username of Docker Hub, I use this variable name, that's that's it. I'll get the user name associated with this credential, and similarly for the password. So this is a build environment, and then we are simply moving into or switching to the directory where we have a build.sh file, and then we are simply calling this build.sh file. This post build action is completely uh, an optional step. Actually, we added this. This is a standard. Again, you can simply copy paste, but we need one additional plugin called post build action. If you don't need, you can simply avoid it. It's not a mandatory step. So basically, we need to pass what image name to be assign it to a Docker image, and where the source code is located, and the branch name, and where is your Docker Hub credentials, and what variables to be used for accessing those. Those are the main things. So once we create the pipeline like this, and we can actually start building the code, and then this particular pipeline will pull the code from the repository which we specified, and then the branch which we specified, and then it starts executing that start.sh, sorry, the build.sh, and then the Docker steps. And then the Docker steps will try to get the image which we specified in that Docker file, like what is the base image name and the image version, and the internal steps that are required for, and the source code will be built, like deploying or installing required components and all. And after that, finally it creates the image, and then it pushes the image to Docker Hub. Now this is just builded this image, and then it is tagged with the Anuvad.io and the image name and the build ID, and then it pushed the image to Docker Hub. This is the Docker Hub. So once this image is build and publish it to Docker Hub registry, in the next deployment step, we can actually use this image name along with the version number and do our deployments. Okay. I'll explain you where we configure the credentials for Docker Hub. But do you have any questions till now?
One thing, the trigger is when you commit to that particular branch. When
That we are
this
not
process
doing.
will.
That we are not doing. That
Okay.
we are not doing currently, because developers often commit even without completing their features.
Okay.
So they usually commit 3 or 4 times for completely committing their changes. Sometimes we observe that. So we didn't enable that, but yeah, there is an option. You can enable it, like whenever you want to execute it uh, on the changes, you can poll SEM, you can do this. It automatically built whenever there is a change in the code.
Okay. Got it. Thanks.
Or you have other triggers also you can enable, like build periodically, or even you can create a trigger and sorry, hook, and you can assign it to your GitHub repository, or you want to build this after some other project, some other API got built or deployed, something like. So it's based on your requirement. So as of now, we are not doing it. We are simply manually initiating the build of the any of the build pipelines, because we want to avoid the overhead on the servers, because developers do commits very often even without completing their full-fledged changes. So to avoid that, we didn't enable.
Okay. Yeah. And what if the build fails? You will get that log there itself.
Yeah, yes. Let me see if I have any other build. Last failure, yeah, this one got failed. You can see for example, the first build failed, third build failed, but second one passed. If you go here and if you go to console output, you can see the error messages, whatever is associated with. This error is actually is about post build process. So you can ignore this. This will never happen if you don't include that extra Groovy script. But the major error is actually, you can see from here actually.
Okay, got it.
Or something from here. Yeah, tag does not exist, something like this. Okay, fail it. And even if you go to some other build that got failed, do we have any recent one? Yeah, front-end dev 20 is failed. Let me see if I can. Yeah, this one. This one got failed due to a folder deletion problem. Like whenever we initiate a build, it tried to delete a folder within the Jenkins server, and it's saying that it tried for 3 times, but it never happened, the deletion of this folder. So it cannot download the latest code from the GitHub repository and continue with the build. So this is an error. So based on the error message, you can see that.
Yeah, got it. Thanks.
Okay, so these are all the build pipelines which we have for all different kind of backend APIs, front-end applications, and sometimes not only the image name you want to provide as a parameter. If you want to provide something else as a parameter, you can even pass that as well. Like say, for example, if you see here we are passing multiple parameters. So when you go to configure, you can add any number of parameters of a specific type. You can go with a string or you can go with a Boolean or something like that. And currently we are using only string parameters, but if you want to add one, for example, I want to add a Boolean parameter or a choice parameter, credential parameter, something like this, string parameter. So you can use whatever is the parameter you want to use, even a file parameter. And then whenever we try to initiate the build, it will start asking you what all the values you want to pass on to those parameters, including this image name. If you want to make the changes, you can make, or you can simply go with the default values and just click on build. And to pass on these variables, these parameters into the application code, we actually have something in the build.sh file. Let me show you that. Yeah, here in this front end, we have a Jenkins file instead of a build.sh. But anyway, even this is the Jenkins file. Ultimately, the real code is written in the sh only. The only outer layer is in the Groovy, like it is saying that, okay, what is your node type? What is your what are the credentials you want to use with your shell script and all? And then finally, the shell script only we write. So you can simply move this out of the Groovy script and simply create a build.sh as well. And here you can see these are the extra parameters which we pass through the pipeline are passing to the application when we are doing a Docker run, so that the additional parameters can pass on to the application from the pipeline itself if you want anything. But if you don't want, you can skip, you can simply ignore it. So these are the additional parameters we use, and the even this one also, if we go to configure and see, this one is also is using the same repo, the develop branch, and it is a Jenkins file. So it's a script path. So the pipeline will be change it, and it's a script path, and then it uses the the Jenkins file. Okay. So
Hello,
the
Raja.
yep.
Yeah, I'm not sure if you already covered it, but how are you managing the environment variables here?
Environment variables for the applications, they're not in the build pipeline. They're not in the build pipeline.
Like, then how are they linked?
I'll come to that.
Okay, fine.
Okay, so there are two different kind of pipelines we are using. When we are using a build.sh, we are using one kind of pipeline which has a different steps. And if we are using a Jenkins file, we are using a simple pipeline kind of pipeline, a basic automated pipeline. And then that just need a Jenkins file. And the Jenkins file is containing both a Groovy script and a shell script. Or if you want to simply pass on the bash script or shell script, you can use this type of pipeline with the bash build. And even you can add a multiple builds as well if you want, or even you can invoke the Gradle script if you want to even use here. Okay, so that's all based on the requirements. Currently, we are using only one step, the build. Okay, so all the build pipelines are responsible for executing either the Jenkins file or the build.sh along with the Docker file, which is associated with that source code folder, and create the Docker image and tag it and push it to a Docker Hub registry or repository, whatever it is. So that's all the build pipelines responsibility. And coming to the release, actually, before even going to release, let me just take you to a credential section. So when you are in any level, you will be actually having a, so sorry, if you are in a parent level, you will have a manage Jenkins, but if you are in a one particular folder level, you have a credential section, or even if you go to your username, and then you will have a credentials again, and you can create the different credentials under this credential section, the global credentials. So you have add credential option, and what kind of credential you want to create. Is it a SSH, or is it a username password, or a GitHub app, or a secret file, whatever it is. So basically we are using username and password based, and you can specify the scope to which you want to give only the Jenkins server and nodes only, or the child items like the all the pipelines and all. So you can go with the global, and you can provide your username, you can provide your password, and some ID naming convention for this that will be visible when you're trying to access the credentials. Say, for example, you put a ABC, then this will be only visible, and the username sometimes, and that's all. So you can add any number of credentials here. Those credentials are accessible within your pipelines when you're trying to build, deploy, whatever you want to do. Okay, if you're using a Groovy script, and with your stage, you can actually provide a credential and what is your username. So if you identify the difference, like in ASR model compute, sorry, here we specified that, okay, this is my credential I want to access with these variable names, the username and password. But when it comes to a Groovy script, that all goes into a single line of code, that is with credential and credential ID. This is your credential ID that we are providing while we are adding the credential. And what is your variable name for the username and the password. So this one line of code actually is similar to this the secrets section, the binding section. And after that, you can use this name wherever you wanted to access this Docker Hub username or the password by using those variable names. So you can see here, Docker Hub user, Docker Hub password. Okay, so this is all about the build pipelines, and the next section is about releasing the applications, these Docker images into a Kubernetes cluster. As of now, in the Ulka, we are using a Kubernetes only, so we deploy these APIs, the front-end applications into Kubernetes. So before we jumping into release and the environment variables, do you have any questions? Anyone has any questions here? I take it as no. Okay. So moving on to release, the deploy. So we have only one particular pipeline for deploying the all kind of APIs, front-end applications, or any other things into the system, the Kubernetes cluster. That's a simple pipeline deploy to and the something like dev, stage, prod. This is actually even the last part of this pipeline name. We are considering it as a namespace in the Kubernetes again. And if we go here, we have a parameters sometimes. So currently we are using multiple parameters, but basically one parameter is required always is the image name. This parameter, which you can copy from your previous build. So if we go to one of our previous builds, and you can see it from the console output saying that, okay, this is the tagged image name. So you have to copy this name like your image name and the image version. This is the image name we require to pass in the on the deploy step. And the other parameters are based on the requirements. So this is purely related to Ulka. So if you want, you can try to add many number of arguments, the parameters like this. But if you don't want, you can simply go with a simple image name parameter only. And the Kubernetes context I'm passing on here because we are using the same Jenkins for deploying the applications into dev, stage, prod environments, and those three environments are with three different Kubernetes clusters. So which cluster you want to connect and deploy your application. So that's the kube context we are passing on here. And if you are targeting to one single Kubernetes from one Jenkins, then you don't require to use this actually. But if you are trying to use a single Jenkins for all, then yes, it is required to configure like this, and then you can use it in your deployment file. Okay, so this pipeline is very simple and straightforward. It has one parameter is mandatory parameter and others are optional. If required, we can use. And where is your deployment source code is located, in which repository you have that. And this repository is actually a non-public repository. So to access this repo, we need a credential. So I linked a credential here, then only this is working. If I say none, it will say that, no, I can't access your repository. I'm not able to access. So sorry, I can't. So we have to pass on the what Okay, we have to pass on the valid credential so that the Jenkins will try to connect to the repository using the credentials we provided and try to fetch the information. So currently I'm using a UAT branch and then the Jenkins file. So when we are using a Jenkins file, we know that it's having everything like a Groovy script and the shell script that I'll show you what is there in this Jenkins file. So mostly this is actually is not required GitHub project. This parameter we are not using anymore because we already migrated to GitHub that already provided here. And we are not even releasing anything in automated way because we are using a single pipeline for deploying all the APIs. And we don't know that the developers wanted to deploy or not as in when they do a build. So we are simply giving an option to the developers by deploy themselves without any automated process. But yeah, we can do that as well. But currently we are not automated. We are not automated the deployments, but we can just simply deploy from here. And coming to the repository, which is linked with this pipeline, as this one, Ulka deploy. Okay, so the Jenkins file which I configured there is this one. This is the Jenkins file. Here we have some steps like we are trying to connect to the Docker Hub credentials, and we are trying to extract the last part of the pipeline name, that is the dev, and then we are actually getting the tag based on that, and then we are trying to apply the environment variables, apply the secrets, and then we do our deployments. And even before that, if we have any arguments to be modified in the files, we are trying to do that. So basically we are passing some parameters here, right, when we try to do a deploy. So these parameters we are trying to replace in the files which we are trying to use for the Kubernetes deployments. And these are all the YAML files we are using for the deployments. Each and every build pipeline, which we have here, has its own deployment profile file called an YAML file within this repo. So ASR model compute, ASR transition, transcription, benchmark download, benchmark metrics, everyone, like every pipeline which we have here is having its own YAML file. That file is responsible for deploying that particular application into the Kubernetes cluster. So here, majorly, the difference between one to another file is the name of the application, name of the service, port numbers we use with the application. So basically, if it is a Python application, we use a 5001. If it is a Java application, we use 8080 or something like that. And how many number of replicas you need and what is your image name. This image tag will be replaced. Sorry, this image tag will be replaced automatically using the image name parameter we passed, and what are the resource limits you want to apply, like CPU, RAM, and what are the environment variables you want to pass on to the that particular API. Like if that application needed a Redis DB connection or a MongoDB connection or a file system, whatever you wanted to give the access to, the environment variables all can be passed here using this env section. And this can have two different kind of environment variables. Like one is with the direct value is linked directly here. What is the name of the environment variable and the value? And values should be enclosed in the double quotes, even if they are especially the numbers and booleans especially. But if it is a string, it's better to put it in a double quotes, otherwise it's not a problem at all. But if it is an integer value, you should put it in the double quote, otherwise it will cause a trouble that it can't store into a string based environment variable. Okay, so we have to, and the another way of adding the environment variables is from the file system. So this is saying that, okay, value from the config map key, and the config map name is common environment. And we have environment variables. We have a config maps dev. Here we specified that, okay, name of the config map is common dev. And we specified all the environment variables here, whatever we wanted by all the applications. So the name of the parameter and the value of the parameter, the environment variable, sorry. And you can link that environment variable from that file using this kind of code. And sometimes even we have secrets, like instead of passing the plain text from the common map, config map, or direct environment variable, if you want to pass anything, encrypted mode or at least encoded mode or something, then you can create a secrets and you can put it with some name, blob storage creds, samba storage creds, redis creds, something like, and you can link that to your application YAML file using the secret key ref. So Redis pass is the name of the environment variable, and the key is associated in the secret key within the registry called Redis cred. So we are trying to get the value from here, and even sometimes from common env, sometimes from direct value. Okay. So, and after that, if you wanted to have any linking with the file system, and if it is a Azure, then you have to create the blob storage and the file share within that blob storage. Let me show you that. Okay, we have a storage accounts concept in the Azure. It supports the table structures, file system, database, everything. So we are currently using for the file system only. So we have, say for example, Ulka production or Ulka prod Samba as one storage account we created. Within this, we created a one file share, and this is having some name with some limit. And then this one comes with some keys and values. Sorry, the key access key. This access key we already have configured in the secrets actually. the secrets.dev. This is the Samba storage blob credentials. This is the account name and this is the account key. These are the two values. This is the account name and this is the account key. We can even see from here. And if the application wanted to connect in a different way, they can use this connection string, but they usually connect it as a folder structure. So we actually configure this within the pipeline by creating the credential secret and the volume mount. And this volume mount is pointing to the secret and the share name Samba share with /opt. So when this application is trying to access the file system of the Samba share, they can whatever the contents are there in the Samba share, that can be easily accessible with the /opt. And if we don't require the volume mount, you can simply ignore it. But if you want a common shared folder, then there is A API, B API. There are two different microservices running from two different applications, and they want to share the file system between each other. Then you can configure a volume mount with some /opt and that linked with Samba storage or a blob storage. And then automatically, if the A API writes a file into that /opt, then the B also can have access to it. And this is an additional configuration we applied on few APIs only, not on all. That is called the horizontal pod autoscaler. So we currently running always with the 2 pods, and we are increasing them to up to 4 based on the CPU utilization. But this will only be applicable when you specify the limits here. Okay. If you don't specify this limit section, the resource limit section, then this horizontal pod autoscaler won't work properly. So we have to apply the limit saying that, okay, my application always should have a minimum request CPU metrics, and then and maximum it can go up to 500 metrics. Then, and when you say 70% out of 500, when it reaches to 350, then it automatically increase the pods from 2 to 3 and then 3 to 4 based on the CPU utilization, and also it can reduce the number of pods automatically based on the utilization. So this is not applied on all the applications or all the APIs, but based on the requirement we applied. If you apply the HPA, this replicas will no longer be considered. But if you don't specify the HPA, that horizontal pod autoscaler, then this replicas is the number of replicas you want to use always for this API. Say I want to run 10 instances all the time, then the replicas should be 10. But this will only be considered when you don't use this configuration. If you use this configuration, there is no use of replicas. You have to specify those minimum number of replicas here 10, and I want to go up to 40 as and when the usage is more, something like this. Okay, so like this, we have individual AML files for each and every API. So basically the name of the service, name of the application, and the port numbers are different. Say, for example, if I take you to Ulka dataset API, here is the port number 8080. But in the Python applications, we use the default 5001 port number. And sometimes we want to use an additional parameters. We can use them. Otherwise, uh, there will be default parameters, and this is the parameter we are replacing with that Jenkins file code. Apart from that, yeah, even after we deploying more than one application into the Kubernetes cluster, we have to serve them together by using one proxy server. That is, we are using Nginx here, and we configure the Nginx with its security SSL certificate and the configuration like auto redirecting from 80 to 443 by default, and what are those certificate files, what are our proxy rules. Like whenever there is a /intro, then it goes to front end intro application or something like that. So we have so many rules here with two different domains, and then 2 or 3 different domains, and we configure here. And this is the deployment of Nginx, and then the load balancer of Nginx, and the horizontal pod autoscaler for Nginx. Like we are running always with 4 minimum, and then it go up to 8. And we are enabling both 80 and 443 port numbers. 80 we are using only for the redirection, as and when the user touches the 80, it automatically redirects to 443. And you want to deploy this Nginx dev to Kubernetes, you have to use the Nginx -dev name, it automatically deploys. So this file name is the name we need to match with the deployment parameter image name. So I want to deploy ASR model compute. Then this ASR model compute should match here, and also the Docker Hub image name. So to this name should match in both the locations, the image name and this YAML file, so that it will be worked. But for Nginx, we are not trying to download any image. We are trying to use this file and then we deploy it. Okay, so this is how we link the configuration environment variables or the secrets, or we deploy the applications, and we execute these all files using the kubectl command that we have configured in the Jenkins file. Let me show you this. Yeah, here we are trying to replace the variables using a set, and then we are using a kubectl config. We are setting up the context, like which environment you want to use, like a dev, prod, stage, and then we are applying the secrets, we are applying the config maps, and then we are applying the current file so that the deployment will happen. And to support the kubectl or the Docker and even these contexts, we actually need to work in the Jenkins server, that we need to install the Docker, we need to give the access to the Jenkins user on the Docker command, and also the sudo rule, actually sudo. And also we have to install the kubectl commands, and then we have to link the Jenkins server with the Kubernetes contexts, that all need to be used for the deployments. And then you simply use this line of code to switch between any context that is available in the Jenkins server, and then you run the kubectl commands to deploy the applications or change the configuration, whatever it is. So this is a single pipeline we use. Say, for example, I want to deploy the Nginx, then I say Nginx dev, then that's it. It will take the Nginx dev.yaml file from the Ulka dev deploy repository, and then it will try to replace the variables which we have in the Nginx dev.yaml, and then it will try to apply the config map, apply the secrets, and then apply the YAML file. That's it. And if we have any Docker image dependency, then we have to even get that. That is not required with this Nginx dev. Any questions?
Begin.
Yeah, nothing as of now. So we are not obviously using Kubernetes at this stage because we don't have microservices. Yeah. So yeah. But maybe we'll have to think about this deployment from when our services will grow. Yeah. So we'll have this discussion later, Arvind, about
Sure.
the next goals of
what
development.
kind of application it is? Is it a simple
So
Java?
Python,
For now, it's a simple web app using Django as a backend and React as a front end.
Okay, is it a it's a different folders only, right? It's not work as a single application, right? The backend and front end run independently or separately?
They are separate. They have their own repo. They are separately deployed also. Yeah, and they interact through API calls. Yeah, so we can.
But yeah, if you're not using Kubernetes, only difference is instead of running kubectl commands here, You need to get the image anyway, and then you need to run the Docker commands here within that particular server. You need to connect to the server and you have to run those Docker commands so that yes, your application will start in that.
Yeah, yeah, makes sense. One thing I wanted to ask, I mean, for different deployment, dev stage, and production, the database that you are using, is it replica across all these three clusters? Is it, I mean, how do you maintain? For now, for example, we are having different databases, but obviously they have different data, and the production will have totally different data than the development one.
Yes,
So we can't test it.
obviously the test environments will not have a real production data in the databases of the dev environment. Even sometimes the database structure also sometimes different because developers do a changes at their local machines and then they apply the table structures at their end, but not applied the same in the production. Sometimes even table structures also are different, data also different. But if we want to make both dev and prod should replicate same, then we do periodic maintenance of replacing the dev instance DB with the prod DB, but that is not required all the time. So because sometimes the developers execute some table update commands, table change commands, or they might create a new table sometimes, and that might not be even promoted to production. So yeah, they will be all, most of the time they will be different.
Okay, yeah. So this periodic syncing happens.
We can do that if required. We can do a manual thing, or even sometimes we can do automated way also. But for Ulka we did a couple of times of manual application, not an automated way, because Ulka has a lot of data in the MongoDB or in the Druid or Druid. So we don't do a complete replication. We do only specific data set data replication. So we did a manually.
Okay. And you're using your own, I mean, hosting your own database as well, rather than using managed ones.
Yes, because this application requires the sharding, and the Azure is not supporting the sharding. It supports the sharding through third-party marketplace PaaS services through Azure, and they are very costly. And currently, we are using our own managed servers, and VMs, and deployed software.
Gotcha.
Any other questions?
Yeah, not from my side. Atharva and Rigved are also in the call, and they're also we are working together on this deployment part. So maybe Atharva, Rigved, any questions from you?
Yep, sure. Yep. Once you start working on this, and then if you got any questions, yeah, we can work together even.
Yeah, that will be helpful. Thanks.
Okay. Yeah, I think we're good. So if no other questions, we can drop off. And
Cool. Thanks a lot, Raja. I think it's a pretty useful session for the team. So yeah, so we'll bug you if anything.
yeah, sure. No problem.
Okay, cool. Yeah,
Uh,
thanks. Yeah.
Thanks. Bye.
Bye.
Thank you.
Thank you.